What's different?
Hi, and welcome to our...
Did you actually just press record?
Yeah, just press record.
Okay.
Welcome to our Const Generic Saturday MVP hits beta recording.
Review?
Yeah,
we review how Const Generics are going MVP at the end of March.
March 25th, 2021. Const Generics is one of the most highly anticipated features. I'm just reading text.
Yeah. So let's introduce the thing so people are not lost.
I figured we'd say why we're doing this in the first place.
Yeah, I think that's a good idea.
Okay,
yeah.
well...
why are we doing this, Yash, on a Saturday?
We're just reminiscing and complaining about it, and that's when we hit record. But yeah, so I guess we were going for coffee today, and we were talking about Const Generic.
Yes, we were.
I asked you if you'd read the
very
blog
different
post.
from a usual Saturday.
I think I asked you if you read the blog post, and you said you didn't.
No, I did not.
And I kind of started chatting, and at some point we arrived at the conclusion maybe this is useful to record.
See if other people might want to know this information.
Yeah.
Yeah.
Admittedly, I haven't read the blog post either, so I figured I'd take the opportunity
to do it live. Sure, let's do it.
Yeah.
Do you want to start?
Yeah, I'll go.
Yeah.
Sure. I believe last time you went first, right?
Yes, you can go first now. I'll be
now.
the gentleman.
All right. Const Generic's MVP hits beta. After more than 3 years since the original RFC for Const Generics was accepted, RFC 2000, which both filed.
Oh, it was them, wasn't it?
Yeah. The first version of Const Generics is now available in the Rust beta channel. Right, so we can use Const Generics without the feature flag. It will be available in the 1.51 release, which is expected to be released on March 25th, 2021. When they expect it to be released, it's very polite because I don't think Rust has ever missed a deadline. Const Generics, I guess it could be delayed, so it's fair. Const Generics is one of the most highly anticipated features coming to Rust. Is that linking to one of Steve's tweets? No, it's not. Oh, Rust survey. Okay, cool. And we're excited for people to start. It would have been funny if it was and we're excited for people to start taking advantage of the increased power of the language following this addition. I'll just finish the paragraph, intro here. Even if you don't know what Const Generics are, in which case, read on, you've likely been benefiting from them. Const Generics already implemented in the Rust standard library to improve the ergonomics of array and diagnostics. More on that below. With Const Generics hitting beta, let's take a quick look at what's actually being stabilized, what this means practically, and what's next. Just realized we need to up the...
That would be good.
All right, you want to take this?
Yes. So what are Const Generics? Const Generics are generic arguments, really, that range over constant values rather than types or lifetimes. This allows, for instance, types to be parameterized by integers. In fact, there has been one example of Const generic types since early on in Rust development, the array types T of n for type T and n of type U size. However, there has previously been no way to abstract over arrays of an arbitrary size. If you wanted to implement a trait for an array of any size, you would have to do so manually for each possible value. For a long time, even the standard library method for arrays were limited to arrays of length at most 32 due to this problem. That would make sense. This restriction has finally lifted in Rust 1.7, a change that was made possible by Const Generics. Here's an example of a type and implementation making use of Const Generics, type wrapping a pair of arrays of the same size. There is an example. Should we do this example in Rust Playground, do you think?
Yeah, we can do that.
I think it'd be good to see maybe not this one, but just a...
So beta channel, we use beta. This is beta from 3 days ago. This was announced 26th.
Yesterday.
So 1 day ago. I think it should like already be in beta. So let's just see, and
Well,
otherwise we can add the feature flag. I just copied over the example.
But you might have to do unimplemented, or
What?
for the impl. There's oh no, it's a comment. Never. On line 7, never mind. Something else.
Well, not a trait. So it would be stud from debug for array pair. Oh, not a trait. Stud from. I just imported it, but let's see what's up. Implement the missing members.
Format.
Oh, I like that.
It gives you to do.
Oh.
Oh my god. We were goofing around before. Will Clippy format this?
Yeah. Execution. That. Formatter not found. Alright, we're gonna fix this. Use stud fund self debug semicolon no. Then we say font there, stud result. We do font results, and then do right. That works. We now have a const param within our array pair. It guarantees that left side and the right side always have the same length.
Nice.
If it's generic.
Cool.
Just start here and we can like alternate or something.
Sure, sounds good.
All right, so current restrictions. I want to highlight. We can do it. Current restrictions. The first iteration of Const generics has been deliberately constrained. Other words, this version is the MVP, minimal viable product, or Const generics. This decision is motivated both by the additional complexity of general Const generics. Oh, that's confusing. Do you mean a general Const generic or MVP Const generic? All right. The implementation for
generics of Const generics.
Yeah, the implementation for general Const generics is not yet complete. Has not yet been generalized. Okay.
Move on.
All right, but we feel Const generics in 151 are already.
I think so.
As well as by desire to introduce a large feature gradually to gain experience with any potential shortcomings and difficulty. We intend to lift these in future Rust, which I believe what's next is later on in this post.
Cool. So only integral types are permitted for const. Right, so probably. So for now, the only types that may be used as the type of a const generic argument are the types of integers, the signed and unsigned integers, including isize and usize, makes sense, as well as char and bool. This.
Called it char.
Yeah, what do you call it?
Kind of reminds me of like share. Like you pronounce it.
Yeah,
like
yeah, like share but char.
Yeah.
What do you say?
Do you say character?
No.
It's short for character.
No, I know it's short for character. I just
interesting.
I don't know. I've always said it char.
It sounds very French to me.
Yeah.
Okay.
Not Quebecois.
Nice. Maybe.
This covers a primary use case of const, namely abstracting over arrays. In the future, this restriction will be lifted to allow more complex types such as nstr and user-defined. Was nstr okay for your pronunciation?
It's fine. It's fine. So, no complex. Ooh, that's a big one.
Yeah.
No complex generic expressions in const arguments. Currently, const parameters may only be instantiated by const arguments of the following form: a standalone const parameter, literal, a concrete constant expression enclosed by braces involving no generic parameters, For example, fascinating. Okay. Okay. This is cool.
This is a good example. I like this example a lot.
Yeah, this one's big. So we have a type foo, which takes one const parameter. There's also like an interesting one where parameters need to be ordered. We now have like a third type of generic. So first one's like, I believe first come lifetimes, then come concrete like type parameters, and then third come const parameters.
Oh, I didn't know there was an order to these.
Yeah. If you don't do it right, you'll get complaints. So I think if we like, before we like properly dive in, if we flip this, we'll get an error, I think. We just saw this was valid. Yeah, reorder the parameters, life types, then const.
Interesting.
Yeah. Yeah, cool. So const params are third kind of param. Makes sense because they're the third like addition. We first had the two which had an ordering, and now these are being added, so they come last in list. If we ever have like a fourth kind, it'll be fourth, but I doubt it. That makes sense. All right. So we're seeing here the const param, pretty much the same as this. We parameterize it using turbofish. If you don't know what turbofish is, you can read about it on turbo.fish. Pretty good.
Good explanation.
Were you emoting a fish? Were you emoting a fish?
Absolutely.
Okay, pretty good.
How do you talk about turbofish? I always do this.
I thought it was like crab hands.
Yeah, but also works for turbo. Right.
So
yeah.
All right.
This is such a non-serious stream.
It's like I've never thought like how to like emote turbofish.
I have always thought about how to emote a turbofish.
It's like interpretative coding. You're like having a dialogue with your code. You're like, and now please turbofish, and the code responds by,
please ensure my lifetime. No, please ensure my lifetime.
All right.
Alors.
So, okay, cool. So here we're seeing like function bar, which calls foo, but function bar also takes a constant, right? And then we see here, because this const like flows through, just like regular generics, we can just pass it along, and that will work. But also concretely, this is fine. 2021, it's fine because we can infer that this type U size.
This can be a U size.
Yeah. Exactly. Here's a fun one: expressions. So, I was like, do I want to like do a complete like side thing? Not really. I think
that one makes sense though. Like it's just an expression that contains.
Yeah, so for people looking at this and being like super daunted by like what's going on,
fair.
You need to like, I think like one core thing to understand about Rust is it's an expression-oriented language. That means that if you have a block, and like for example, this won't be valid. I'm gonna flip these around. No, behind the scenes.
I can also do the typing. I brought my own keyboard.
Yeah, but I don't want like dictate.
Sure.
That seemed like not very.
Yeah, I don't like when you dictate.
I know you don't. So we can do let a equals 12 U size times 2 or something, right? And then we don't have a semicolon here, and like the final expression within the block that doesn't have a semicolon, it's assigned back to the
variable.
Yeah, it's like a soft return from that block, which is different from like a hard return. If we did this, return says return from the function, right? So this is just like an expression which evaluates to a value, and you can do this infinitely all the way through. This is how like match statements also have like return types, assignments. It's quite nice, I think.
Right.
And what we see here again is we can have const expressions where we would place the parameters. Effectively, because we are allowed to have a literal value, Rust pretty much has a rule. I think it might be a substitution rule. I don't know. But it's like wherever you can use a literal, you can use an expression.
Right.
Because we can use literals here, we can use expressions there.
I think that makes sense.
So that's kind of fun. Now that's what's allowed right now. Like you can pass in const params, like the generics themselves, literals, but also expressions because these are equivalent. However, not every kind of expression is valid yet. Right?
Yeah.
So here we say we take the param m and we add 1. That won't work. 2, that's beyond the MVP state. Or when we say give us the size of t, that won't work. There's a fun one here. You can use bits for type t instead. Usually,
really?
yeah. No, type t, no. Sometimes you can use bits. If you know a type, you can use bits, and that will like work.
Perhaps that's too much of a segue.
It's instead of like size of. It's nice. Yeah. It's been added last patch, which is nice. Error const expression contains a generic parameter t, so that won't work. Oh, you can't initialize arrays by a const param yet. Oh, you can. That makes sense. Yeah, that's normal. That's what we saw here.
But you can do a size of
Yep.
That's similar to kind of the boot or size of.
Yeah, exactly. So here's a really interesting one, I think. It's like people might look at the foo n+1 one here and are like, why would I ever want to do something like this? You can start expressing stuff like, say we take an input array and we create some sort of output array.
Yeah, but you want
we might, for example, say like we take 2 input arrays and the resulting output array is the length of both of the inputs.
Yeah, so you
we then do like n plus m, that new array size of this other type or something like that, of type t. Both arrays are type t, different lengths, and the resulting length of the output type is like n plus m. There's interesting stuff around that. Have you ever like heard of dependent types?
No, I have not. Is that a Rust thing or?
No. It's like, so within type system, there's like tons of like different types, linear type, sum type, dependent types is one of them.
Can you give me an example?
No, it's like type theory stuff.
Okay.
And like in Haskell, they have like plugins to add this kind of stuff.
Okay.
But essentially, like dependent types, I'm not an expert, so I might not know the exact phrasing, but it allows you to start describing computation, rules, constraints within the type system or the computation that happens within the function body.
Okay.
And we're sort of getting into that area here where we're saying the output length of this thing is twice the combined length of the input, the 2 input types.
Oh, neat.
Right? So it becomes interesting, like in what you can describe. And I bet there's like some sort of overlap into starting to prove programs, prove their correctness. The more can be like done and compiled, the more can be proven. Some overlap. I don't know how far it goes and like the exact trade-offs Rust cannot make because there are limitations. But it's pretty interesting to sort of see the direction that this is like heading and enabling. But yeah.
Cool.
All right.
So should we move on to the by value array? Okay, so by value array iterator, in addition to the language changes described above, we've also started adding methods to the standard library taking advantage of generic. While most are not yet ready for stabilization in this version, there's one method that has been stabilized. Array into iter allows arrays to be iterated by value rather than by reference. Addressing a significant shortcoming. That's neat. Very neat. There is ongoing discussion about the possibility of implementing into iterator directly for arrays, though there are backwards compatibility concerns that still have to be addressed. Into iter new acts as an interim solution that makes working with arrays significantly simpler. I'm curious to try this out because I think a lot of people are probably used to doing array into iter and working with that kind of
Yeah.
and that's kind of neat. Let's see.
I'm very curious about these backwards.
You want to segue into those quickly
Not
before
yet,
we
not
do
yet. Kinda. I'm just very curious. Okay, Lucas. Words compat problem.
Oh, can you zoom in on this?
Yeah,
Because
yeah,
even the person with glasses can.
Adding this impl is not as straight as it seems. Backward compatibility hazards. Due to autoref, this compiles to x into iter, and then x is a reference. Does this change? This code wouldn't compile anymore as x is inside the loop. Cool and not. Only happens when you dot method into iter for loops.
Where are they using the dot method call?
Dot method.
Oh, just then like dot into iter.
Yeah. Not the auto conversion.
Okay.
Right. There's been some discussion. 1000, etc. Creator run would be good. I really hope we do get into it. I'll explain like it. But like, okay, if this is the extent of it, okay, that's good.
If this is the extent of it, you're into this backwards breaking compatibility change.
Was yeah.
Spill the tea.
No. It's like if stuff like critically breaks, like I don't want to get into it like too much.
Okay.
But like some degree of breakage, like always accepted when like off the happy path, right? Like if you may, it's a question of like if a tree falls in the woods, no one's there to observe it. Did the tree truly fall? Right? Something happens and nobody like witnesses or nobody's impacted by it. It's the same case here. Like if this breaks, is a breaking change. Pretty much no code is impacted by this. Very little code.
How do you know there is?
We have the creator project. Rust has a creator project that allows testing every single crate on crates.io.
What?
With a change. Yeah. So you have the patch, you say run this patch on Crater, builds a new version of the compiler.
That's amazing. I didn't know that was a
Yeah, so it does two things. First, it checks like, do all these crates like compile currently?
Yeah.
Right? And then it checks with the new compiler. Do they still compile?
How long does that take?
Very long. It's very expensive.
Like I feel like that's like a.
But this is like a major language feature kind of thing, right? Major ergonomics thing. So being able to test it. Now the downside of it is like as Rust has like gained more adoption, there's like dark mass of code bases on tests because it's like you have to code companies.
Right.
So people are getting a little bit nervous about like, does this practice? Oh, there's some questions there. On the flip side is maybe some mechanism can be construed. We can ask companies to do creator runs within, like internally. Please hook into the system and then go through this, that we make sure that we never get access to your infrastructure, but we still get the feedback whether or not we broke you.
Right.
Right.
It does require people to like be to be involved in.
Yep.
People are usually wanting to be involved with.
I mean, some companies are going so far as to like push compiler teams.
Yeah, fair.
So, there's a question here, like how this will be resolved. I'm not saying that I have insight knowledge. Like there are like definitely like tensions constraint. But Crater, like figuring out like does this code break stuff? Does this change actually break anything? Is very useful. So I'm curious like how this will just I guess like my feeling is like if this doesn't like dramatically break like all of Crit.io, even less than that, you know, if it's like if the breakage is like manageable, this would be half work.
Right, but should we look at what?
Yeah, totally.
Of the actual example that moment.
It was like a small tangent there. Sorry.
Right. Should we do this one?
Yes.
I can do the typing this time.
Yeah, you can take the mouse.
Oh, wow.
Yeah.
At least I don't have to bring my own mouse. I brought my own keyboard though. Look. Why? Thank you. Right. So, we want the array, and then probably want to do the array thing they do. Your mouse is.
Up here.
I can hold my own mouse thing. Shit. I don't know how to Windows. I brought my own keyboard, but I don't know how to Windows. Clippy is gonna.
No, you're not. Yeah.
Oh, I meant press format.
Yeah.
I click press format, but I said Clippy. Cool. So let's run and see what that gives us. Right. Well. This should compile. Yeah. Cool.
Amazing.
This is super neat, I think.
You can like just directly like iterate over like get references. That's so good.
I think it's super useful. The number of times I've done it where I had to
just like for reference, like for people who are like, okay, but what are you talking about like with all the changes and the maybe breakage?
Oh yeah, we should probably show what we want to do now.
We want to like have this work. I'm curious what the error is that we're going to see now.
Yeah, that's a good one to see.
Unused import.
Well, what is R?
What was it? Oh, what? The uppercase by accident.
Oh yeah.
Makes sense. It's not an integer or call.iter. Iterate over it.
Yeah.
Fired by. It should just iterator new.
Interesting. Are we on the latest beta?
Yeah. Well. Yeah.
Yeah.
Like it's not wrong. I'm just channeling my Esteban.
Okay.
Where it's like, you know, we just like have this new feature where it says array into iterator new, and like a good diagnostic. The correct resolution here is to then use array into iterator new.
Sounds like a patch to be done to the.
It doesn't suggest it. It just says like you can either borrow it, call.iter.
And I think it should just probably do borrow call.iter or do into iter new.
Exactly, because if you borrow it now, it's wrong, right? Because we're not getting vec, we're getting nvec.
Yeah, so you got to do the to iter to actually make this work.
So
but
iter.
I don't know why it suggests the borrowing thing.
Oh, it's equivalent. So if you have a borrow.
No. I know that point. It's just like I guess it should iter into.
Yeah, so the into iter trait isn't implemented on it. So the regular diagnostics don't see it implemented on it. They suggest it.
I see. That makes sense. Okay.
So instead it says like, oh, but I do see this error trait, and kind of needs to be specialized. I don't know if there's any like good way to do this. Ideally, it would be specialized, and that suggests into iter new. And if that constraint's ever take away a specialization for the diagnostic. Make sense?
Yeah,
Right,
totally.
cool.
I think what's next?
All right. What's next? Const generics and default arguments. Generic parameters must currently come in a specific order: lifetimes, types, const, like we saw. However, this causes difficulties when one attempts to use default parameters or default arguments alongside const parameters. For the compiler to know, so for people wondering like what a default argument is, type results. How do I define that? Right, I'm just gonna pull up the. So we had like the debug impl earlier.
Yeah.
Right, and the right hand side of this was filmed result.
Yeah.
But you can do filmed result if you want to, but you don't need to.
Right.
Because
where are you going with this?
By default, it has a default output. It has a default argument.
Yeah.
So I'm just pulling this up. Right. And we see here, does it even like have a default? No, it's just hard coded. Anyway, the way you can define defaults is you can very often just say like foo t and equals by default unit on foo. Am I getting the arguments right? Yeah, something like that. Right, and then t something like, if you don't parameterize the type by default, it defaults to that thing, otherwise it doesn't.
So I guess what they're suggesting is it would be good if we could have a default instead of the unit having a default of a const.
What? The
Was
unit?
it? Well, you said that in your example you had unit as an of a default value.
Oh, wait, no, this is wrong. That gives a type. For example, we could do 12.
So instead we'd want like a const in the future. Right? Yes. Well, I'm just trying to tie it back to what we were reading.
No, yeah, you're right. I guess I'm just like very confused about like the example I was trying to give because it isn't quite correct. Maybe like a better one is like applicator stuff. Recently got like primes. I'm not making any.
I think we should continue reading.
Let's continue on. I was like, yeah, let me do a clarifying example. And I sent myself like off a cliff, like what? But yes.
Typical.
A little bit.
A little bit.
All right. So for a compiler to know which generic argument is which, any default arguments need to be last. Oh, that's a fourth kind. Kind of.
Okay.
It's like it wants to be second kind, but it was already third kind. So the ordering between like do const or default params come first is uncertain.
Right.
These two constraints, types come before consts and defaults come last. Hey, conflict with each other for definitions that have default type arguments and const parameters.
Okay.
That's the solution to this is to relax the ordering constraints so that const parameters may precede type arguments. Oh, interesting. However, there turn out to be subtleties involved in implementing this change because the Rust compiler currently makes assumptions about parameter ordering that require some delicacy to remove. Ah, interesting.
It's probably a little. What is in which order? What is in which place? Probably a bit difficult to figure out what.
Yeah.
By Rust C.
It's somewhat clear though because like a const param is.
Yeah, I guess the const param has const.
Yeah, it's like const x.
Yeah.
And the other one is like foo equals 12, right?
Yeah. Well, I've never looked at the compiler code, but I assume it's probably, if it's taking some time, I'm assuming it's a little bit complicated.
It like my bigger worry here would be if the parsing would become ambiguous, right? Like if it's hard to discern like it's a const param or not, but they took care of that like properly. And so all they do is like relax them. Seems like mostly a parsing thing, but they're saying there's some difficulty involved. So it's like, I bet like all the error handling infrastructure
revolves around, yeah.
For example, probably much other stuff. In light of similar design questions around defaults for const arguments, okay, so defaults for const arguments, so you can have a const equals some default.
Yeah, that makes sense for const. They're also currently not.
What? In light of similar design questions around defaults for const arguments, these are also currently not supported in version 1. Whatever. Okay. However, fixing the parameter ordering issues above will also defaults. Oh, that's huge. So simply like the ordering stuff will, out of that falls like const default.
I think that makes sense from like a parsing perspective. Error.
Interesting. I would have like imagined maybe there would be like more stuff, but they're saying no, pretty much done. We just need to get the parsing figured out, and then it's done.
Defaults are probably implemented a very similar for both const types. I'd assume, but perhaps not.
Can I get some?
Sparkling water.
All right. You want to take next?
Sure. Const generics for custom types. For a type to be valid in theory as a type for a const parameter, we must be able to compare values of that type at compile time. Furthermore, quality of values should be well behaved, namely it should be deterministic, reflexive, symmetric, transitive. To guarantee these properties, the concept of structural equality was introduced in the const generics. Essentially, this includes any type with derived partial equal and equal, whose members also satisfy structural equality. There are still some questions concerning precisely how structural equality should behave and prerequisites for implementation. Primitive types are significantly simpler, and I think that makes sense, which has allowed us us to stabilize const generics for these types before.
I have definitely run into issues with structural eq before. Do you know about that?
No, I don't know what that is.
So structural eq. With marker structural eq. I think this may be forever like unstable. I'm not too sure. But this falls out. Right. So if you do derive partial eq, your type also implements structural.
By default, okay.
However, if one of your member types has a custom like equality implementation, it no longer implements structural.
Okay, but you cannot implement structural eq on your own unless you're on nightly.
Exactly.
Okay.
So I forget why this is. I definitely needed it at some point where I was like, oh,
what partial eq magic were you doing?
I had like some sort of like constant partial eq. I just wanted to like ignore a field.
Okay.
Right, where what was it? It was something with right types or something. I need to be like, either you're initialized like this or initialized like this, but whichever one you are, then do an equal. Right. That like left or right doesn't matter as long as one of them is initialized. Like that wouldn't like work. So there was something where I needed it. I forget like what the constraint is, like what you need this for again. Because they're like, well, equality of value should be well behaved, deterministic, reflexive, symmetric, and transitive.
Do you think equality of values will get pats for being well behaved?
I like it. That's good.
Very proud. So proud.
Yeah. And so, I forget like what I needed it for. They talk about it in the RC, which let's not pull that up. Maybe they explain it here actually. Here we go. Required trait for constants used in pattern matching.
Okay.
There we go. I remember what I was using it for. I want people to do match requests dot what was it again? Media type or something. My request dot media type, some HTTP server, and then it would be like media type HTML. Like if it matches that, then we parse it as like HTML.
Yeah.
As XML, as CSS, as like the other thing, right?
Yeah.
And because of the way I like implement media type and the way the constant was defined or something like that, we weren't using partial eq.
So you had your own partial eq implementation.
Exactly, and we could no longer. This could no longer be used like that. Essentially, we're just waiting on this like.
Well, it seems like they're aware.
Yeah, so it's being worked on, which is pretty exciting. I wonder if like this trait will actually, or it'll just like always work. I guess we'll see.
Time shall tell.
Time shall tell. Did you? Yeah, you took this one.
Yeah, you go in the next one.
All right. Const generics with complex expressions. Interesting. Oh yeah, so that's the n+1, n plus, etc.
Yeah. Stuff we talked about.
Several complexities involved supporting complex expressions. A feature flag, const evaluatable checked, mouthful, is available in the nightly channel, which enables a version of complex expression support generics. One difficulty lies in the necessity of having some way to compare unevaluated constants. The compiler does not automatically know that two syntactically identical expressions are actually equal. Okay, wait, hold on. I need to parse that sentence there just for a sec. Of having some way to... Yeah, go ahead.
Yeah. So, like, you have an evaluated constant, and you have, like, a number, 1, but because it's... You want to be able to make sure that those two are actually the same in the compiler.
Yeah, I'm somewhat like fascinated by the word does not automatically know that two syntactic identical expressions.
Yeah, the syntax
actually equal, because it says the syntax is the same, therefore it is the same.
Yeah, I wonder if it's like the
and like what?
Because it's you have an n is a u size, let's say, and 1 can be in.
Oh, you're just looking at the example.
Well, yeah.
Oh, I was just reading the text.
Oh,
I was trying to understand like what it meant.
I guess if I can't understand the text, I look at the example and kind of do the two together.
Oh yeah, well, you're entirely right. So the fact that n+1 here equals n+1 there.
Yes, exactly. It's trying. It cannot automatically figure that out.
It doesn't yet know that.
Yeah.
And therefore, this is valid. Oh yeah, like it. So here's a funny one, right? You can't assume that you can't do an evaluation of both of these and then look at the output and see if they're the same, because sometimes like different formulas might have the same. Right? So that wouldn't work. So it needs to actually say like at a type level, this is the same thing.
Yeah, I guess it has to like compare the n and the 1 and the fact that it's a... Oh, hold on. N is a u size, so it actually has to coerce the...
What?
Oh, never mind.
No, this is an array.
Yeah. I'm like 5 steps ahead. I don't know. Sorry.
Okay. Yeah.
I'll move myself.
Okay. So just for reference, like the length param is always a u size.
Yes.
Okay.
Yes.
Cool. Then we good. All right. Sorry. This makes sense. This involves a kind of symbolic reasoning about expressions, which is a complex problem in general. Sense, because we need to now equate these two. That could be like in very random places. And also you got to imagine like super complex, like nested, like 5 layers deep kind of expression. We should still like, yeah, this is the same thing. Right? We also want a way to deal with potential errors when evaluating generic operations. So potential errors, head tail split first.
NETs. Oh my god, I'm lost in the
So here we say, okay.
Okay, yeah, I got it.
Like
that took a while.
So this is like a variation on what I said earlier of like you have two arrays of two lengths, right? And then you output like one array of the combined length. There's the inverse. You have one array of length n, and then you output one item and an array of n minus one because you just took the first item.
Yeah, I guess that's like a pop.
Exactly. Like on the heap.
Yeah.
Stack. Whoop. So without a way to restrict the possible values of m here, calling generic function 0 would cause an error when evaluating 0 minus 1. Sense.
Yeah. It has not caught a declaration time and may.
There are design questions about how exactly to express these kinds of bounds, okay, which need to be addressed before stabilizing lexicon.
As a segue, there is like stabilizing with the Z and stabilizing with the S. I love it. I love it. Anyways, you want to look at the arguments that people are posing about this.
I knew you would like comment on that when you like were like as a segue. I was like, it's this, it's that, 100%. All right.
This looks better with an S.
British.
Right. So
when we have a const expression, generic parameter in it, be sure that const expression is valid. Yada yada yada. That makes just even like open anymore. Wait, has this been resolved? They're like, here's an open question, and then it links to a closed issue.
What? There are design questions about how exactly to express these kinds of values, which need to be addressed before stabilizing. Is there a link to PR or something? Is this issue or PR?
This was discussed, yada yada yada. It is just issue. And then closed, which signals to me like this is done. I'm confused now.
Ollie had a clarification.
Yeah, but that's like sort of like a discussion. Okay, here. Ollie closes it. Yeah, I meant that. I didn't realize entering unchecked. Please open issues on the RFC repository or even better discussion.
Okay, so this is still an ongoing discussion, but this.
Alright, so I don't know what status is. But maybe what this thread just covers is like the considerations are. Yeah. Not so much the current status, but just like what has been discussed here.
Yeah, what people.
That makes sense. Right.
Summary. With such a major new feature, there are likely to be a few rough edges. If you encounter any problems, even if it's as minor as confusing errors, please open an issue. We want user experience as best it can possibly be, and issues now are likely to be even more important for the next iteration. Cool.
We found an issue. So we just file it?
Sure, yes.
All right, cool. Well, we just do that as part of this. In this case, there is a diagnostic issue.
Yeah.
Right? Create a bug report or feature request for a change to REST's error out.
I've never opened an issue.
All right.
Let's. No, it's okay. I'm gonna get notifications.
You want to remain anonymous?
Yeah. As we film a video, I just feel like there's gonna be lots of discussion, and then I'm gonna be tagged in all those.
No, I'm pretty sure it'll just be like, oh, good catch, or like dupe. Maybe like there'll be like one-step labeling.
Okay.
And the other one's like, oh yeah, good point, and then someone will resolve it. But just link back to here again. So title. What was the error again?
Yeah. No.
Iteration, right?
Yeah, iteration, but then I didn't suggest the into iter. So if you copy that and remove the into iter.
So there's a template here to follow. Convenient. And the preview. Given the following code, the current output is ideally the output look like.
Perfect. Okay, cool. Let's just dump the code and current error.
So given the following code, this. Oh yeah, you're right. Okay. And we said we remove this.
Yeah, and just R.
There.
I think you might have to put it into function main.
Oh. Yep. Then we do Rust format. So one extra helpful one. Do a run, verify that's correct.
Yeah, and that's the borrow the array with I'm losing my voice. What were you gonna run it with?
So we can do a share. Link to playground.
Oh yeah, that'd be good to add.
Given following code, create a quick little link. Please provide a link to. Oh, there we go. They even ask for it. Make that a little nicer.
Your round bracket is.
Oof. Following code. That the output.
Did we just copy the borrow the array to the whole thing? Do you want to do the after the little ticks? Oh no, that's one. I thought you did.
Never get that. The proposed output is borrow the array with. So what we want people to
Use the array into.
And we say call. What was that over here? Borrow the array with an or call over it. Iterate over it.
Should we keep the borrow the array with?
It's like that. That is not the right output.
Yeah, no, I mean,
like if people were to follow that suggestion, it leads to broken code.
Yeah, I guess.
Like currently, this is the only way to like lead to correct passing code. Like I prefer to like sort of share like the exact solution. Leave diagnostics people to interpret that solution and like apply it to what is currently possible. Right? Because maybe we don't have the full context.
Yeah, it's fair.
They can make that trade-off.
Sure. Let's submit it as that.
And then there's help text here. Node arrays are not iterators, but are help. The trait array is not implemented for. I'll delete the nodes here. They're just not helpful. Try to change code.
I think you should probably.
Yeah, we're on beta 151.
Beta 3.
24. The date.
Okay.
Oh, I guess yeah, beta 3. Run RVAS 1.51.0. beta dot 3 2021 02 2.
Do you mean run in the past tense, or do you use run?
No, we have ran on and here following.
Oh, that's good.
And following the const generics beta MVP blog post. We ran into the following error. Into diagnostics error. Blog post specifically requests filing related diagnostics issues. So here goes. Diagnostics suggest using, what is it called? Array into iterator new. Using over arrays.
Code, current output, ideally the output like Rust. That looks good to me.
Probably move that here. Will help text.
Yeah.
And then finally, over it, the array, because it is unclear. Borrow the array with empty into iterator.
That seems
Just clear enough that people understand it. New issue?
7 new issue.
Cool. Oh. So yeah, I guess that's the whole thing.
Yeah. Wrap it up out here.
Yep, I think so. All right.
That's a wrap.
Thanks everyone.
Ciao.